All right, welcome everyone. We have quite a few of you on already, but we are going to give just a little bit more time for those as they begin. Yeah, there's others jumping on now. So we're just going to give just another, say, 2 minutes before we get started. So hang with us. All right, I know there are some others that are jumping on, but we're going to go ahead and get started. We have a lot to cover today. Hello, everyone. Thanks for joining us for today's webinar, which is part 1 in a 2-part webinar series focusing on advanced planning and scheduling. Today's session, which I'm particularly excited about, features an expert panel discussion on how advanced planning and scheduling supports lean initiatives. I'm Chris Brewer. I'm the Customer Development Manager for ATS Lean Scheduling International. Before we get started, I'd like to introduce our panel of experts to you. First, we have Dr. Shirukurani. Dr. Irani is the president of Lean and Flexible, a consulting company that delivers advisory, training, and implementation services focused on lean for high mix, low volume manufacturing. You may know that as Job Shop Lean. He has an extensive resume, but I'd like to acknowledge he was an associate professor at Ohio State University, where his research produced a comprehensive methodology to adapt lean for high mix, low volume, small to medium enterprises. He also has recently released a book entitled Job Shop Lean, an industrial engineering approach to implementing lean in high mix, low volume production systems. So be sure and follow up with him about his book. I'd also like to introduce Paul Mittendorf. Paul is the Director of Manufacturing Systems at Orbiger Corporation of America in Pompano Beach, Florida. And it's interesting, Paul, he is a long-standing APS customer of ours. We did his implementation some years ago and have worked closely with him. But it's interesting because he's also personally worked with Dr. Irani on lean initiatives there at his Florida facility. So welcome those two gentlemen. And from the ATS side, we have two guys who have decades worth of experience in APS, ERP, MES, and all those acronyms that we all know and love. First is Martijn Donkersloot. Martijn serves as the APS Business Development Manager for ATS Global. He's worked hands-on with clients on their APS implementations for the past 10 years, and before that, he specialized in ERP. And likewise, Hans Albright, who serves as Vice President of Sales and Marketing for ATS Lean Scheduling International, has spent the last 20 years both selling and implementing APS and ERP solutions. And actually before that time, he spent time as a production scheduler. So he truly understands the complexity and the needs and the demands of manufacturing, planning, and scheduling. Again, we'd like to welcome you here today and know that you're going to have many valuable takeaways. But I'd like to go ahead and get us started by focusing in on lean. So at this time, I'm going to ask that Sharuk shares his screen. And Sharuk, if you don't mind, will you just provide a quick summary of lean in your words and experience? I think that's a good way to get us started.
Sure. Thank you, Chris. Thank you, everybody, for having me on this panel. I'm also honored to reconnect with Paul, with whom I've worked at Orbiger Corporation. So this is basically a presentation where I thought a title was how to make it viable for high mix, low volume, variable volume, make to order discrete manufacturers to implement lean. And I personally have experience to vouch for the fact that APS, finite capacity scheduling in every which way, is a big compliment. and lean complements APS, APS complements lean. So please don't think that either of them is inappropriate. So what is lean? When I stepped into the arena, uh, the quick understanding was, and I think everybody should understand that you've got two dimensions of manufacturing. This x-axis is the variety, and you might say we either make a low variety of product or we produce a high variety of product. Okay, and appropriately, you've got quantity. Either we are a low volume producer of many products or we are a high volume producer of products. So in the process, you get at least four quadrants or four domains of manufacturing: high volume, low mix, low volume, low mix, high volume, high mix, low volume, high mix. And so if you will notice, Toyota is way out here, and all the other manufacturing systems are way out here. And lean is just essentially a way to think about running the business. So here's my own definition, which came to me from a colleague, and it's a manufacturing philosophy. And the philosophy is basically saying, look, there's a customer wait time to them ordering and something from us and to them receiving the order from us. And that total wait time is administrative lead time and production lead time. Okay, so the total time between the receipt of a customer order and the shipment of that order to the customer. And essentially what we have between those two dates is a lot of non-value added work. These are called the 7 forms of waste. And effectively, from a time perspective, from a competition perspective, these wastes translate to delays and costs. So the costs take away from your profit margin, and the delays are what make it uncompetitive for you against some other competitor who can deliver that order faster, better, cheaper to customers. So what are these wastes? And this has been going on for years, but what you should understand is that these are what kill your costs and these are what increase your delays. So when you quote a lead time and a due date to a customer, you have essentially factored in all the delays that you will experience due to quality problems, due to producing stuff you should not be producing when you inflate a lot size, a lot of queuing which will occur inside your manufacturing system, a lot of transportation both inside the facility and from supplier facilities, a lot of inventory, a lot of operator motion, and a lot of unnecessary processing steps. So what lean essentially does is it attacks these wastes with the cognition that if you eliminate these wastes, you are eliminating the production delays, and by eliminating the production delays, you're able to quote extremely competitive lead times to your customers. So that's essentially a foundation for lean. If you have questions, do send them on later.
Excellent. And before we move on, I'd like to just have one follow-up question here with you, because you showed the different forms of styles of manufacturing. So do you differ in the way you implement lean in high mix, make to order environments versus low mix, make to stock environments?
Yes, I think that the quickest understanding is that when you are make to order, you essentially have a due date. You have a due date to fulfill, and you don't have any finished goods inventory on which to rely on in order to fulfill that particular order sent by the customer. Now, when you contrast that with Toyota, they have all their dealerships. So they look very good producing a whole bunch of cars, but guess what? That is overproduction waste. And that overproduction waste is hiding in full view on their 1,500 or so dealership lots in just the US. So as far as, implementing lean in high mix, low volume, I still go back to the principles of lean. So principle one is specify value from the standpoint of the end customer. So in this case, it is deliver the order by the due date of the right quality at the right cost. The second principle is you've got to identify all the steps in the value stream, which is understand the way your products will be produced. The third principle is minimize the material flow delays that will occur inside your factory and in your supplier facilities. And the fourth principle is you pull schedule. Do not release orders into the manufacturing facility if you know that your bottlenecks will not be able to keep up. And then the fifth principle is continuous improvement. Once you have improved one value stream, one product family, go back and improve the next product family. So I'm not going to bore you folks with details, but what you should understand and be extremely, extremely knowledgeable about is that when you start implementing the principles of lean, on the left side here, these are all the tools that you will hear of. They call them the lean tools. And even I agree that in high mix, low volume contexts, yes, you will use these tools. But please understand, the high variety of product you make will still make it a challenge to implement these tools. They are good. They are universally relevant. But there is still going to be the challenge, how do I use these tools for a variety of product? But on the right side, here, on the right side, and I caution all of you, and that's why I think that this webinar is an extremely important message, that if you look at these tools on the right side, which is what you will keep hearing about lean, they will work fine in the Toyota production system. If you are in an assembly context, if you can get away with make to stock, yes, you can have flexible assembly lines. Yes, you can make a variety of product, but be cautious. You are still making an automobile on any one of Toyota's lines. You will not see dishwashers. You will not see refrigerators going down those lines. So where does APS belong? Right here. Do you see? Assembly line balancing doesn't apply in make to order. Value stream mapping is extremely ineffective the way it is used. One piece flow cells, good luck. Kanban, first in, first out, all of these tools which are used for production planning, control, and scheduling in a low mix, high volume environment, they just do not fit the high mix, low volume, make to order environment. So essentially, my message is that unless you are open minded and say lean is going to work hand in glove with APS, I think you're unnecessarily complicating your lives. And I think when you start to implement lean in high mix, low volumes, you should look to this right side and say, you know what? What are all the tools that I need that will enable me to replace these tools, which would not work in a high mix, low volume environment, and introduce tools that would work? And I think in the context of today's presentation, APS is one of those extremely important tools, because that way you take care of principle number 4, which is pull scheduling, work order release against true knowledge of capacity constraints, which can only come about through a good, viable schedule being produced by the APS. My colleague Paul will tell you the details. He's done that, but I'm just leading into his presentation. Thank you.
Excellent, and that's a beautiful segue there, because I was actually just about to go to Paul here, and all of this sounds all too familiar for you, I know. So you've worked with Shiruk there, or bigger, on your lean initiative. So from your side of things there, what's your experience surrounding the principles in your shop floor environment, Paul?
Okay, a couple areas that will basically back up what Shiruk said there. If you stay looking at his slide there, which is a good one to start off on, there are clearly things that can help you with lean concepts wherever you are. Like, I'm going to bring up the 5S. Everyone can agree that if you apply 5S principles through your plant, you're going to get improvements. You're going to see incremental positives and betterments in your plant. How much is dependent on how bad things were in the first place. But where things fall apart, particularly in a high mix, low volume environment, like I have at Herbiger, when people start coming in and we're talking scheduling using takt time. I'll give you an example where that is disastrous. Let me give you a little background of my environment so you understand that. Herbiger literally has over 400,000 part numbers. We manufacture from that queue of part numbers. 70% of our work can come from 120,000 part numbers. Our orders can be from one piece to as high as 100 for it. Now, what's interesting is I have a shop floor with many routes through it, which we'll get to in a moment for value stream mapping, where I can have one job on a machine today that'll take 15, 20 minutes of machining time. And the next job up online will take a day and a half of that machine's machining time. When you start looking at that, tack time will start falling out the window because we, to use Shiruk's example, we make washing machines and we make cars. We make small little radios and we make big giant machines. So tack time is not as relevant. You could sit back and say over a year, this is how many pieces I made divided by a year and come up with a number. But did that really help you for scheduling? I've seen too often people come in with tack times trying to say, I got to take this assembly line or this production line and I have to get this machine producing 80 widgets an hour. Like, that's not going to happen. I have one widget taking 4 hours and the next widget is 5 minutes. So that doesn't work that well. In those environments, when you have such a wild swing of machine times or process, we'll call it just process time, because it's not just machines. It could be people-oriented processes. Like in our case, we have an area of cell where we have to perform deburring operations on finished parts to make sure the last little bits are cleaned up. We have staff, or we have an assembly department that has people doing this. In all of these cases, a key function that APS brings to the table is a ability to viably and quickly create a best schedule to keep your resources optimized and working on the best possible workflow to achieve, as Shiruk said, which is one of our #1 goals, on-time delivery to the customer. In my environment, I have some things I go through sometime for training when I bring this to new employees. I point out that if you only had a handful of jobs going through your plant, you could pull up Excel, or as Shiruk has their paper and pencil solution, you could try to schedule your plant. You could recognize things like, I have 3 jobs that are going to this work center, that if they all go to the same machine, I could save an hour and a half of setup time because it's got the right tooling. Okay, that's very good. That's optimized. That's lean thinking. Now try to do that when you have 90 CNC machines and you have 1,200 orders on the floor, all due in 5 to 6 days. You can't do that. Now, the good news is you can apply those principles and those thought processes, and you can apply those to creating rules and systems in an APS that can take this huge amount of data and create a viable schedule for you. Over time, I have seen time and again that people will look at a schedule and wonder, why are we making this part on this machine at this time? And in pretty much every case, I can go through and show them the data, and they're like, yeah, that makes total sense, because at the time they couldn't see the big picture. What's on the other machines? What's due up tomorrow? What's coming up on that machine in an hour? Who's not coming in today? What shift is down on a machine? What jobs do I have to send out for an outside process that I can't do in-house that takes longer to ship it out and bring it back? These are classic examples where an APS fits. And again, with a wide audience, I'll give you an example that maybe some of you can resonate with. You have 2 jobs that are due on the same day, but one of them you have to send out for a heat treating or a painting or some sort of special process by welding by another vendor outside your company. Well, clearly in your head, you know you have to start that one a little earlier to make your end time with everything else, because it's going to take longer. You have to transport it out. You have to give them time to work on it. Then it's got to come back. And APS allows you to see those things, schedule those things, and dynamically present a schedule that the shop floor can see and say, oh, okay, if I work in this schedule in this order on this machine, I'm going to get the right part at the right place at the right time. So those have been my experiences. To give a quick update or a quick information picture for what it can do for you. We've been running this for over 12 years now. And when we started 12 years ago, we had a crisis moment in our plant where we were just struggling with how do we get the right job to the right place? How do we get all these pieces together? We make primarily an assembled item. And at Herbiger, I tell people, if you scored 95% on time or 95% in a test in high school, you got an A. Well, at Herbiger, that's an F, because that entire package is still sitting on the floor waiting for that one part that got delayed. And this was, well, disastrous. We just had so many total shipments to the customer late. And when we go through and we analyze it, it's just like one part here, one part there that just didn't make it. And it wasn't well scheduled. So we decided to go this route and put it in APS. And after a long development, or not too long development, in a pilot program, we flipped the switch on the plant. And I honestly felt that I would see a 10, maybe 15% increase in output. No, we got 30% in a week. 1 week later, no changes of routers, no changes of employees, no changes of machines. We took a look at our earned hours coming out in our parts, and it was 30% increase, literally in a week's training. It was a big job. It was a big motivational thing and a big change management thing in the plant. But it was combining lean concepts with APS, with an MES system on the floor, and activating these so they tie together with our ERP system. And it can really pay dividends. It is a more difficult thing. I mean, let's be honest here. When we look at the list of things and people come in and say you have to do lean, 5S is usually the first thing they jump on. Why? Because it's the quick, isolated, walk through the plant, focus in small areas and improve it. And it's a good thing, but it's not going to give you that kind of improvements where the big picture can be affected by the bigger activities. So that's a little background on the history and what I experienced when we moved over to an APS and an MES system.
Excellent. Thank you, Paul. And I certainly want to come back to you in a few minutes to kind of discuss APS a little bit more in depth with you. And by the way, there is a wonderful case study that we've done over the Herbiger case. It's on the lean scheduling website. It's lean-scheduling.com. Be sure to check that out under case studies if you want more about that. And Paul, again, we'll come back to you in a moment, but I don't want to assume that all of our attendees really know the basics of APS. Some people may be on here and have no real understanding of what advanced planning and scheduling is or how it works. So shift the conversation just a little bit and just get to the basics of APS. Hans, Martijn, I'd like to go to you guys and just ask that question, and that is, what is advanced planning and scheduling? So I'll let you take it there, Hans.
All right, great. Thanks, Chris. So I've got a slide I just shared, and hopefully everyone can see that right now. And this is a definition that I have worked with. It's kind of an evolving definition, but this really does capture it primarily, what APS is. First and foremost, my first bullet point there is planning and scheduling software that uses finite capacity scheduling engines. And the real key there is that finite capacity, because there are lots of tools that enable you to sequence jobs. Maybe ERP systems will give you a list with due dates and that type of thing. But if you're not accounting for the true finite capacity, it's just not real. It's just not real. You're just throwing everything into a bucket, and some of it will make it and some of it won't. And so having that finite capacity as a starting point is crucial. My second point there then is that these systems, these planning and scheduling systems, can be really basic, where you're just lining up jobs, run rate scheduling. We just know this machine runs at this speed, and we just know we're going to be able to get X number of widgets out in this time period. It could be that simple to multi-constraint scheduling that uses advanced scheduling rules. The key there is that it's to match the business and production environment of the end user, and that can be a very wide range. So on the one end, you have the very simple. On the other, you may have situations like we have with food customers, where they might have 6 or 8 different steps in the process, but we start in the middle and then have to schedule bi-directionally in order to give them the best possible schedule. Well, to try to do that with spreadsheets or paper and pencil, that type of thing is just a non-starter. You'll never be able to successfully do that kind of thing. I don't know, Martijn, if maybe you have some examples of other, the range of APS systems that you've seen or that you've dealt with over time.
Yeah, thank you, Hans. Yeah, well, what we normally see is that the majority of the companies still using manual systems or Excel-based systems to create schedules, and we all know that's a very complex puzzle, very time-consuming activity. And even if the planning department is able to create a schedule with a high accuracy, we all know that something will happen. So something unexpected will occur on a day-to-day basis. So you can think about rush orders that need attention now to avoid delivery lateness, order inquiries, machine breakdowns, operators leaving home sick, material shortages. Well, we all know those circumstances. So as a result, even if you were able to create an accurate schedule, it will become inaccurate immediately, and then the shop floor becomes a real black box for the planning department. They are not able to keep it up to date anymore. And so, having said that, creating a schedule is one thing, and for sure there are 95% of the customers use Excel for that. But once it changes, they are not able to keep it up to date anymore because you need to reschedule. You're not able to reschedule. You need to create a new schedule by the use of Excel. And I remember a company a couple of years ago, a metal extrusion company. They had a fire in a part of their plant, and it was all over the news in the next day. So, and of course, customers started to call them immediately because they wanted to cancel their orders. And you can imagine that it's impossible to reschedule a 3 months horizon. But by the use of their scheduling system, they were able to reschedule in 15 minutes. And they informed all their customers before 10 a.m. in the morning about the new delivery dates. So although it's an extreme example, I know, but it illustrates that they were able to save hundreds of thousands of euros in 15 minutes, just because they have the insight and the ability to reschedule.
Wow, great. That's a great example. That trumps mine. That's very powerful. Okay, so that was, again, that was the second bullet point. Again, these systems can range from very simple to very complex, and can be very, very powerful. As far as with the output then, so you have this schedule, you have a person who sits down and they work the schedule, they get things aligned, they optimize and so forth. And the output of that is an accurate and optimized schedule of jobs on the resources, and they're based on the real world limitations. And this is a lot of what Martijn was just alluding to as well. And so that's really key, real world, right? You have employees who come in, who don't come in at the last minute. You've got to make some changes to a large order, or maybe your tooling, you have limited tooling, your tooling has failed, numerous different issues like that come up. The APS system is designed to handle those things, and the output of that then is this schedule. And then that schedule, and my fourth point here, is it's presented in a way that's graphical, it's interactive, so that you can do multiple what if scenarios. Well, what if I take this order? What if this changes? What if I took this line down? What if we have this, what if we do this preventative maintenance tomorrow? What would that look like? These types of what if scenarios that you can do very quickly. And so it's graphical, it's interactive, and it's a plan that everyone can see it, and it's easy for everyone to understand. So in 4 bullet points and a lot of verbiage, that's what APS is.
Excellent. Thank you guys for that. And I'm glad that you kind of provided that baseline, because now I would really like to go back over to Paul here. You've already kind of told us a little bit of the benefit that you reaped from APS, but Paul, what was your expectation from APS when you first started the project versus, you know, the outcome that you actually got? What did that look like?
Our original first expectations were to allow us to have a better, broader view of the plant, to try to line up our parts. As mentioned, a significant portion of our business is a fully assembled product. And we knew we were having problems getting all the components all at the same time. When we first started, and maybe this is a key thing for APS implementation, we first started, as everyone likes to do, with the concept of a pilot program. And one of the failures we had up front with our first project was we scoped it on a section of our plant where we make a certain product line that had certain machines there, and it sounded like a good idea at the beginning. But where we made a mistake in our implementation was, in order for that section of the plant to make their products, they needed to have certain steel cut in a certain sequence to feed into it. Think of it as a big black box. And so when we first started putting this in, we were struggling with, why couldn't we get this schedule that worked? Why couldn't we work to a schedule? Why wasn't it making any improvements? And we quickly ascertained that in our particular environment, we had a section we called the steel room, which actually sliced up and cut pieces of steel, and they fed multiple areas of the plant. And if the steel wasn't available for the area of our pilot program, they were never going to succeed. So what we learned on that is we had to back up and bring this steel department into the planning system so that we could actually control what it was making for what area of the plant, and that totally controlled the schedule. That was an initial expectation. We thought it'd apply on a small area and apply it to a small area. But what we learned was the small area we thought we were going to pilot on was not really a true black box. It was totally affected by an upstream process with the steel material supplying area, and that we had to get that one into this program to be able to control that area's schedule as well in order to satisfy all areas as best as possible. So I guess in summary there, a finding, we first walked in with expectations that, oh, this will be the best thing since sliced bread. We're going to improve our schedules. We're going to be more on time. And we realized we had to expand some scope, or we realized that there were some areas that we had to change our view to include in the APS. Once we included it, things got really good. I won't go through wonderful details of how literally on that pilot period, within a span of 4 weeks, we went from huge amounts of late to the supervisor of that area. We said, you don't need to come to the meeting for operations. You're not late with anything. It was literally a night and day change. But I will let everyone know that our first pilot program was not the success we thought, because we didn't wrap all the elements into our planning that we needed to. So that's an important thing to think about when you look at scope of a project like this.
Absolutely, and thank you, Paul. To take that there, I'd like to go back to Shiruk here, and just ask, you know, now that we've kind of discussed a little bit about APS, how do you think that APS fits into the high mix, make to order environments that want to implement lean?
Sure. So let me go back and review a little thing. So you've seen these principles of lean, and principles 2, 3, 4 are the heart and soul. So going back to Paul's statement, principle number 2 essentially says you should understand that you can't go and en masse try to refine and transform the entire high mix facility at one shot. You have to go piece at a time, and each piece is a product family. So that's the first challenge. Identify your product family. Second step is streamline the logistics, the physical movement from raw to finished goods, everything from steel arriving to shrink wrapped pallet being put on the truck. think of that product family's physical logistics from point to point, detail by detail. And then the third thing is principle 4, which is schedule your facility against realistic constraints of capacity, raw material availability, labor availability. So that's principles 2, 3, 4, right? So to your question, that's essentially principle 4. What does APS do? It takes that monster, principle number 4, and makes it possible in a make-to-order environment where you cannot rely on finished goods inventory. So I'm going to go back and lean or cheat or steal from Paul's work, and much of this implementing lean principle 4 is what he and I did way back when. So this is the first thing. Get a schedule that can be implemented, and it's not just a Gantt chart, pretty colorful slide, coming off of Preactor or now Siemens Op Center. Do you have the correct standards for cycle time? Do you have the correct standards for setup time? Are you able to account for sequence dependent changes? How reliable is the transfer delay from Op 10 to Op 20? How do machinists know that their tools are available, that their gauges are available, their boring bars are available? So the first thing is, get a viable schedule that you are confident can be executed every day. So that's basically what Paul made possible. Not only could he produce the schedule, but he was confident it could be executed through the combination of people and the factory viewer manufacturing execution system, right? So this is essentially the work of Op Center, Siemens Op Center. Second, this is the complete loop that Paul implemented. He went from order intake into SAP, into the Preactor schedule, into the execution by the factory viewer manufacturing execution system, and then the status update at the end of every shift was fed back to SAP because new orders may have arrived in that period, and then the rescheduling was done. So this loop is not just an IT exercise. This loop is a combination of IT and IE, industrial engineering, which is the whole shop floor execution. So you've got to really, really know all the data elements, all the data documents, and all the files which are going to have to be updated with this loop, which is SAP to APS to MES back to SAP. Of course, I would today probably add in MMS, which is the machine monitoring systems. But remember we talked about error proofing and visual control and 5S. Let me tell you how Paul did this in the context of scheduling. So every CNC machinist had a screen. And what that gentleman got to see, or gentlewoman got to see, was a certain set of jobs only. Even though there were a bunch of active jobs on the floor, even though Preactor had scheduled, say, 10 jobs to that machine, he or she only got to see at most 3 jobs. Why? You do not allow operators to cherry pick, because if one machinist cherry picks and disrupts their job schedule at their machine, boom, the entire shop gets disrupted. So you know how in the theory of constraints, the gold video, we had, the entire scout pack walking to the beat of Herbie? Same thing here. Do not muck up the schedule, because if you muck up the schedule, everybody starts running around like ants in a fire. So APS being implemented, everything starts with even bucketing the order. So many times, how do people use their wonderful ERP system, like SAP, stops all production, right? They get an order, customer gives them a due date, and the production scheduler, sales marketing people devotedly, yes sir, we accept that due date. They drop the order, and then they backward schedule. There is absolutely no consideration for available capacities and prior commitments in the schedule. With APS and with this completely nicely looped system and a competent director of manufacturing systems, you basically are implementing what is most difficult in make to order, a viable schedule. The only thing that I would add though, in my experience, is the water spider. These water spiders, essentially are logistics people. And, software and IT cannot run the shop floor. So what I have found, how to say, be effective is we try to free up employees through lean activities. And now these employees which are freed up, at least one of them is repurposed as a water spider. In the army, they talk of situational awareness. That's what the water spider basically brings along with this APS integrated suite. They bring that ability to react to unexpected changes, and even if the schedule executes, they're able to make these adjustments on the fly. Oh, a batch of parts arrived, two of them had to be rejected. Oh, a tool just broke. Oops, a machine just broke. Ah, Tom just called in sick. The schedule cannot adapt. And sometimes between the combination of good supervisors and the water spiders, you're actually able to make sure that the schedule which was produced actually gets executed. So all I can say is that be true to the principles of lean. It's a very good systematic process. There are details to implementing each step. But principle number 4, implementing the scheduling system, should be preceded by principles 2 and 3. Know your product families, and 2, streamline the physical material flow of each product family, and 3, unleash the power of the system that Paul's put together.
Excellent. Thank you, Shiruk. And I appreciate so much that you went ahead and kind of showed how Paul's system is integrated there. And you talked a bit about a pre-actor, which is now Ops Center planning and scheduling. And it's a data-fed system. It's all about the data and closing that loop, as you just showed, and how all these systems are integrated, communicating with one another. So Paul, from your perspective, how does APS complement the MES and ERP systems?
The pre-actor or semantic APS system allows you to apply a large set of complex rules. For instance, I'm going to use that example there. My organization uses SAP as our ERP system, and we get planned manufacturing orders to satisfy our demand, but it basically gives a window saying I need to make part A and I need to have it by this date. It has routers, which many people are familiar with, which will define I have to make this part, I have to go through these work centers, and this is how much time it takes there. But what it fails to recognize are things where within a work center, jobs can have variable times based on sequence. I'm going to use a simple example here that many can get very quickly. We have part of our organization, we have an injection molding area. And when you're doing injection molding, your molding machines can increase temperature faster than they can cool down. So if you're starting them up in the morning and you have jobs that you have to execute that use multiple materials, an advanced planning system can take that information from your ERP and say, okay, let's do them in this order on these machines in this sequence because we're going to get more out in the day rather than turning it around and changing materials so that we have to cool the machine down longer. There are constraints and information that exist on your plant floor because of your resources, your people, your knowledge, that an MRP doesn't know. It's never going to know. Another example, let's say you have a work center that is out on the floor, but you know that for Mondays and Tuesdays, it's going to be less productive because you have a less skilled crew in there and they're just training up. With an APS, you can put that information in, even if it's only for a few weeks, to adjust the schedule where your MRP would have no idea. It doesn't know. And these are where you can bring the details of the floor and put it into this bigger picture. So an APS is able to take your concepts and your rules and your experiences from various areas, from production supervisors to machine capabilities, et cetera, and create a system that could take all this information and make a big picture that becomes a best schedule at the time you make it. For instance, Shiruk brought up a good point. What if you make your schedule and you're planning to run some jobs tonight after midnight, but you find out that the machines you're going to run it on broke? They went down. This is a point where also with an APS system, you could rapidly reschedule. Martin brought up the point of a plant that had a fire and within a short amount of time could replan their entire production. This is what APS can bring to the table. If you are today spending all kinds of effort planning with paper and pencil and Excel spreadsheet, ask yourself the question, how fast can that be redone when something goes wrong? What if a machine goes down? What if a shift changes? What if suddenly you want to plan next week that a whole 2 machines are down for maintenance? APS brings you that ability. It takes your exercises of small paper and pencil. You can do this with Excel and small paper and pencil and magnifies it many times over to take in all this information and create a best schedule. So that's what I would bring up as a summary as where it really fits in, to take this large amount of information and very efficiently make a best schedule. And more importantly, be able to make it again later when something changes.
Absolutely. Thank you, Paul. And just for those that are listening, you know, when we talk about integrating to these systems, yes, Paul uses SAP and Factory Viewer, but the beautiful thing is that our software, it will integrate to essentially any of these systems that you may already have in place. If the data is available, we've yet to find a system that we can't integrate to close that loop. We have just a few minutes left here at the end, and so just for the next few moments, I'd like to just kind of throw it back over to Hans and Martijn, and kind of just tell us a little bit from your experience in implementing APS in job shop discrete manufacturing environments.
I'll take the lead on that if you don't mind, Martin. So I would say, you know, for me, the product, when it was first developed as Preactor and is now OpCenter APS, Siemens Corporation has rebranded it, it was originally designed for a job shop environment. So it's, you know, it went from that. I mean, it's great with all the sub-assemblies, keeping everything synchronized and so forth. It's just designed to do that. But I will say beyond that, it then has evolved in an incredible way that makes it flexible enough to fit into just about any industry. Most industries with some understanding of the problems, you know, you're able to even see problems, scheduling problems that are common across multiple industries. We have seen a problem, a scheduling problem that was the same, that took the same solution in one customer that makes pastrami and another customer that does titanium castings. The problem having to do with the dipping process and the oven process, it was the same problem. So the key here is that this has evolved to handle really complex situations, and you'd be surprised the different industries that this will fit into. Martijn, I know that you probably have had more implementation experience with this than I actually have. I'd love to hear your take on that question.
Yeah, thank you, Hans. So, besides all the features we can offer and all the planning rules we can create and stuff like that, we also need to consider where is a customer today. So what is their current situation? How mature are their processes? And for sure, during the sales process, the sales presentation, the demonstrations, yeah, we do a great job, but we normally discover that most of the customers will benefit from these solutions in several areas, by the way. So, and what I discovered is that the biggest challenge is then to together with the customer determine what is minimum needed for them for the first scope of the project. So don't try to capture everything and utilize every free at once. Actually, don't get too antsy, but keep it simple in the beginning. Yeah, you need to get used to the system. There's a new working methodology involved. Change management needs time. So my advice is that you and your supplier, you need to investigate how you could benefit from the solution in a very short period of time. Also allowing you to get a very quick return on investment, and consider this starting point as the the first phase of your digitalization journey, the first step in a future improvement process. That's exactly what I discovered in the last decade. That that's the biggest pitfall, to try to automate everything at once. And
yeah, that's good advice. And we implement according to that principle as well. We kind of follow this 80-20 rule, where we want to just shoot to get 80% of it done and get people functional and address the primary problems, and then do some revision work, some refining as the customer is used to working with it and begins to realize some value. They also understand that things they thought they needed, they don't need after they work with it, right? Yeah. So your point is so valid. Start simple, focus on the key problems, and then go from there. That was very good.
Excellent. Thank you guys for that. And essentially that covers the majority of what we were going to discuss here today. And it's such a tease because we've talked about all of this, and we're going to have to kick the rest of it to next week. We just don't have the time. And next week we will actually dig into the presentation of the software itself. So you'll get an overview and see a sneak peek of the tool. We're also going to discuss the ease of scheduling using APS, the benefits of implementing, and whether or not APS is the right solution for you. And that's next week, April 20th, the same time. If you've registered for today, you're already registered for next week. So you're not going to want to miss it, because it's going to take what you've heard today and bring it to life by actually seeing the software, seeing how it works. It's, the intricate little pieces. And, today was such a great session. There was so much knowledge, and it's more than just words. I mean, these guys that talk to you today, they've been there. They've done this for many years, and they actually have the experience, and they've gotten their hands dirty. So what you've heard is more than just words from, trying to pitch something to you. This is actual experience in real life implementation regarding APS and Lean. So Hans, Martijn, Shiruk, Paul, thank you guys so much for your time today and for everything that you brought to the table. All of the attendees, thank you again for joining us. As you see on your screen now, if you want to follow up with us in the meantime, we would love to talk to you. If you have questions, if you just want to make some comments, please reach out to us there. You see the website, lean-scheduling.com. You can also go to the ATS Global website. There's contact pages there. The email address directly is info@lean-scheduling.com, or there's a phone number to reach the Bradenton, Florida office of ATS Lean Scheduling International. We hope that you enjoy the rest of your day, and we will see you again this time next week. Thank you all.
Thank you, everyone.
Thank you.
Yep.
Thank you, everyone.